Hello and welcome to episode 4 of How to Code a Game Like Minecraft in Unity. I'll apologise up front if I sound terrible. Somebody made a comment in one of the previous videos about me struggling to speak through the fact that I'm not used to talking on a microphone. This week I'm struggling to speak because I physically cannot breathe half the time. I'm hopped up on cough sweets and green tea and whatever. So if you hear a bit of coughing and wheezing, this is not a right lot I can do about it, and I didn't want to put this video off any longer than I had to, especially after the wait you all had for the previous video. So we'll get straight into it. In this one, we're going to handle chunk generation. So in the last one, where we left off, we had our single chunk generated in the middle there. In this video, we're going to generate multiple chunks and have the game handle that generation rather than us having it set up here. Before we get into that, I just want to change one little thing. I think I said that I was going to have my air block be 255 in the in this index in the block types. That's not going to work because it's an array. I can't have a 255 without the previous 254 being there. So we're going to have air block as 0, which I think is how Minecraft does it, but I could be wrong. But what that means, it's not going to have any bearing on this episode because we're not going to introduce air blocks just yet. The whole chunk is completely solid top to bottom the way we are doing it at the minute, but we're just going to fix that now while it's in my head. So if we just duplicate bedrock and we'll change, but it doesn't really matter what these are, but we'll just set them all to 0. We want to make this one, we'll call it air, obviously, and the only difference is it's not solid. Like I say, for now, it makes absolutely no difference, but it does mean we're going to have to change in here. This is no longer 0. This is now 1. And this will be 2, and we'll leave that 3 because now we've shuffled them up. That will make that a grass block as opposed to a furnace block. Obviously, we don't want it as a furnace block. That was just to demonstrate the texture. So the first thing we're going to do to start our chunk generation is we're going to get rid of our chunk object because we're no longer going to be using that. And then if we go into our chunk class, we're going to change it. It's no longer going to be a mono behavior because what it is we're going to have a lot of stuff to keep a track on, and the more stuff there is, obviously, the more system intensive it gets. We want to be able to control all that, and it's a lot easier to control everything if we have it in one place. And we don't want every single chunk mesh to have its own script running, doing its own thing that we have to try and keep control of. So we're going to take all that away from the object. The object is just going to be a dumb game object with a mesh. It's not going to have any script on it whatsoever. So obviously we're going to copy this because we're going to need that, and then we'll get rid of the start method altogether. And in its place, we're going to have a constructor. And in that constructor, we're going to take in our world reference. Because if you remember me saying, the game object find function that we were using before is quite expensive relative to what it is. And you don't want to be using it on a lot of objects, and we're going to be generating a lot of chunks on the fly, and it's an unnecessary lag spike that it could create. So what we're going to do is we're going to take in the world reference here, and then we don't have to go looking for it. So we can just immediately say world equals world, and then we've got our world reference. And what we had before, all that, we're just going to stick that there. So whenever a new chunk is initialized, this obviously will run. But we're going to need a few more values. Obviously, we need a mesh render and a mesh filter. Just take they no longer need to be public. And we're also going to need a game object, because now we're not starting with a game object. We're going to create one on the fly. So we'll just call it chunk object, but spelt with a J. And that will be... Wow. Typing is on point. Chunk objects equals new game object. Got there in the end. And then for mesh filter, it's going to be chunk object dot add component. And then that will both add the component to our new game object and at the same time apply our reference to the to this value that we need. And then we do the same for mesh renderer. Really sorry about the typing. Blame all the drugs. So they're the references that we need. And then we also need a material, which I can't remember. Is that public? Yeah, so material is here in the world class and it's public. And since we have a reference to our world class, we can get it straight from there. So mesh renderer dot material equals world dot material. And one last thing we'll do just to keep things all nice and neat and tidy is we will set our parent for this, so we don't just have loads of chunks generating in the hierarchy, we want them all in one place. We'll set our parent to world.transform. Of course you have to actually use the set parent function. So now we want to go into our world class. And we're going to have to create, we'll just get rid of that, we don't need to look at that for now. Create a start function. And all we really need to do here is we'll just say chunk, new chunk equals new chunk. That's pretty much it. And we obviously we need to pass in the world, and that should be that. Now we should be back to where we started, but now obviously we're generating that chunk on the fly. It's been put in here all nice and neat, and we can work from there. So now it's a lot easier for us to create new chunks on the fly. So before we move on, there's a few extra things we're going to have to create, or that I want to create. One of them is a new class. We're going to call this one, actually I think it would make more sense if we had it in the chunk class. So we will put this down here, public, I'm going to call it chunk chord, and it will make more sense as to what that is in a second. Oops, sorry. All kinds of befuddled. And what this is going to do is, it's kind of like a vector2, but it's holding an int rather than a float. We only need two values, public int x and public int z. And what this is it's the position of the chunk that we are drawing, but not in world space. So if we imagine the chunks were, like in Minecraft, the chunks are 16 by 16. So chunk number 1 would be at 0, and then the next chunk would be at 16, and then the chunk after that would be at 32, and so on. This is not that. That's the absolute world space. This is the chunk position within the chunk map, I guess you call it. So in this one, chunk 1 would be 0, and then the next one would be 1, and the next one would be 2. So this is completely different to the absolute position. And again, we're going to need a constructor to make life way easier. Ooh, Jesus. Then all it's going to be is x equals underscore x, z equals underscore z. And now we want to keep a reference to this up here. So this, we'll make this one public actually, just cause. We'll just call this chord. And we want to take in this value here. So this is what's going to tell this chunk where it is in the world. Chunk chord. You know what, actually, we want that before the world reference. That's the most important piece of information. Underscore chord. So card equals underscore card, and then what we can do with that is we can position, now that we have a reference to some kind of positioning information. I know I said that the chunk guard is not the position information, but we can get the position information. We can work out the position from this. So once we've set our parent, we will do chunk object dot transform dot position equals new vector3, and then we want chord dot x times voxel data dot chunk width. We know it's going to be at 0 on the y position, and then we want the same again for the z. And just to make things a bit easier to follow along in the inspector and everything, we'll just set its name using this data as well. Just to make things a little easier to follow along. So now in world, obviously we have to pass that information. So just to show it working, we'll create a new chunk card 0 0, and then again nothing much will have changed except for the fact that now it's got a name. And if we go in here and copy this and we put one there, oh, I will need to give it a different name though. New chunk 2. We should have 2 chunks right next to each other, and they're appropriately labeled and filed away under world just the way we want them. Now obviously we don't want to have to write this out every time we want to generate a chunk, so we're going to create a new class now. Now this function can be quite simple because basically the generate world function will be different to the code that we will write to update the world. So as the player moves through the world, as more chunks are generated and loaded and all that sort of thing, that will be different to this. This function is just run the once when the game's first launched and when you're first thrown into the world. That's the only time that this function will run. So we don't need to get too complicated with this. So what we're going to, before we do this actually, sorry, we're going to need a new value in here. And that, if you haven't guessed, which I think you probably have, is going to be the world size function. And we're going to call it world size in chunks because we're going to have a world size in blocks or in voxels as well. So we need to distinguish between the two. And for now, we're just going to set it at, we'll go with 5. It's really not important for now. This is just for testing. I don't want to set a massive number because it is going to take some time to load each time we run it, and I don't want you to sit waiting 30 seconds every time I run the game. So now that we've got that value, we need some for loops. Oh, head is all over the place. X is now less than our new value, world size in chunks, and it wants to be -1. Actually, ignore that. It will need to be -1, but it doesn't yet, and there's no point in putting it there before you know why. And then obviously x ++, and then we will just copy that for Z. Need to get around to turning off Visual Studio's propensity to auto-arrange my curly brackets. And then in here, we can just create chunk, new chunk equals new chunk, no, new chunk with a new chunk called of xz, and obviously a reference to the world. And we'll get rid of these, and in their place we'll just call our generate world function. So now we have an error. Oh yeah, if you're going to create a new function, make sure you close the brackets on that function. So now if we wait for it to catch up and we run this, there we have a 5x5 world now, made up of these chunks. So we're getting there a bit closer, and you can see down here they're all nicely organized so that when you're developing you can get to you can figure things out easier. If a particular chunk's not showing up the way it is supposed to do, you'll be able to figure out which chunk it is without any unnecessary, I don't know, counting or something. So now we need to start keeping track of things, and this is where the -1 thing that I was talking about comes in. So what we're going to do is we're going to have a chunks map kind of thing, although it's not really a map, it's more of a list, I guess. We're just going to call it chunks, and it is going to be the world size in chunks by world size in chunks. It's a 2-dimensional array, x and z. And then what we're going to do when we call this here, instead of creating a new chunk, creating this new chunk, new chunk, or whatever, we're going to put it into this array, and the position in this array will be the x and z that we are passing to it. So the position will correspond to its actual chunk coordinates. So we're going to go chunks x z equals. So again, absolutely no difference when we run the game, but now we have a reference to these chunks. Now they don't just exist in the game, they also exist in this array, and we can find them, which is going to be important shortly. So now, before we move on, we're just going to do a few little things that will make life a little bit easier going forward. So the first thing is we're going to move this, because we are going to have to do a few other things later on when we create a new chunk other than just this part. So we're going to put this in its own little function, which will be aptly named create new chunk. And we will pass in a we'll pass in a int x and an int z. Cut this out and put it there. As I say, it doesn't make any difference now, but we are going to have to do some other stuff along with this when we create a new chunk at some point quite soon, so we may as well just get this out of the way now. We also are going to need a few other little additional functions. One such function is, well actually it already exists, but we're going to move it into a neater place. So we're going to take this code here and put that in its own function. We'll just stick it here for now. Bool is voxel in chunk. We'll pass in the 3 ints. So if it's below 0 or out of... bearing in mind this is a local value. When we're talking within the chunk, we're just talking about the voxels in that chunk. So 0 is the start of the chunk. Even if that chunk is world position 2058, 0, as far as this chunk is concerned, is the left-hand side of the chunk. It doesn't matter where it is in the world. So this is all local information that we're talking about. So int xyz locally. So if it's less than 0 or greater than chunk width, then we know it is not in this chunk. I'm going to return false. Otherwise, it is in this chunk, and we'll return true. Then we're just going to replace this if here with if not is in is voxel in chunk. And we pass in the xyz. Again, that makes no difference. It's just a handy function that we are going to need this function for other things now that we have it. And then we're going to do a couple of other little things that will come in a bit, such as we're going to need to be able to turn our chunk on and off. So we'll do that with we'll just call it is active, I guess. This one's going to need to be public. It's going to need to be a function. Is active. Actually, we'll do it this way. Public bool is active. And we're going to return the chunk object's state if anyone asks, which is active self. So if we ever ask if we just read is active, it will just return the chunk object's active self state. Whereas if we want to set it, we need to use the chunk object set active function. Oh Jesus! I'm passing the value. 15 typos later, and then just one more. We're gonna have a public vector3 position. This is just completely pointless, really. It just saves us having to type certain stuff out over and over again whenever we need particular information. So this position means that we can access a position data for this chunk rather than going in chunk object transform position every time we need it. And this is going to be read only because we're never going to set the chunk position from in here. So it's only going to be a get, and it's going to return chunk object.transform.position. Now in here, in world, we're going to want a similar function to isVoxAll in chunk, only it's going to be isChunk in world. So we'll just create a new function, bool isChunk in world. And we're going to have to pass in a value for this one, and it's going to be a chunk card because we have the class, so we may as well use it. And all it's going to be is if chord.x is greater than 0, and chord.x is less than voxel data dot chunk world size in chunks, and it has to be for this one. Oh sorry, that needs to be a -1 because now I need to do that there as well. This needs to be -1 because we're working with an array, so we don't go to the full. I mean, if you remember, an array of 16 will end at 15 because it starts at 0. So you still got 16 spots, but it only goes up to 15 because 0 counts as one of those spots. So you need that -1. So if it is all those things, it is in the world, and we return true. Else, it is not in the world, and we return false. And another thing, so we also want to be able to check if a voxel is in the world. And the way we're going to do that is, first off, we're going to create another value in here. And this one is going to be a int. And this one's going to be world size in voxels. And we're not going to store this value because we have all the information we need to calculate the value here. So rather than store it and have to change it, we're just going to calculate it on the fly. Obviously it's going to be read only because you can't change this value. None of these values should be getting changed during the game. So to get that, we want to return world size in chunks times chunk width. And then we're going to create a new function, again, bool is voxel in world. This time we're going to pass in a vector 3. And it's a very similar situation. So we've got pos.x is less than 0. No, sorry, greater than 0. And pos.x is less than voxel data dot world size in voxels. And then again we want and then we have to repeat for all the other ones, so we're just going to copy them for now. Make life a little bit easier. So again, these need to be -1. And obviously we need to change, we don't want to just check against x 3 times in a row. X, Y, and Z, and then and this one, because it's Y, we're not checking against the world size, we're checking against chunk height. So if this condition matches true, then we are in the world and we can return true. Else, we want to return false. And then the one final thing we're going to do is we are moving our where the hell is it? We're moving our check. No, sorry, it's not our check. It's get voxel, which I appear to have lost. Oh, it's there. It's because we haven't made it yet. Sorry, we are moving this code out of here and into its own script, its own function. Sorry, in here. It's going to be public because the chunk needs to be able to get to this code. Get voxel, we will call it. And this is going to be the most important. This function is going to become the engine that drives your Minecraft world generation thing. When we talk about the Minecraft level generation, world generation algorithm, this function that we're about to create now is essentially my version of that algorithm. Obviously, it's starting off. It's going to be very, very simple. But as it gets more complicated, you'll see how it decides where to put caves, where to put a biome or whatever. All of that will happen in this function. So we need to pass a position, and basically all this function is going to do is we're going to pass in a position to it, and it's going to give us a voxel ID. So it wants to be a byte wherever that is in the world. So we need to change this. So instead of adding it to a voxel map, it's returning it. And of course you don't need equal signs when you're returning. And then we need to put pos.y. And at the minute we're only using the y value to decide anything, but that will change. And then if we go back in here, we want, voxel map x, y, z now equals world dot get voxel new vector 3 x y z. Now nothing should have changed, and we haven't really done a right lot in terms of what's going to affect the game, but I just want to quickly run it just to make sure there aren't any typos that I've missed or anything like that. Everything's still running as it should. Yeah. Right, okay, so we're not quite there yet, as you just noticed when I zoomed in. If you remember, we went to a lot of trouble to draw the chunk from the outside as a mesh so that we didn't have each voxel having all its 6 sides when you don't need them. You don't need to see a side that is obscured by another voxel. Now we have the same problem, but now with chunks. As you can see, if you zoom in here, all the chunks are drawing all the way around the outside. Now, we're going to have to deal with this properly, but for this tutorial, the easiest way to get around this is, well, first off, we're going to add in here a little check, just to make sure that whatever voxel we're currently working on is voxel in world, and we're going to pass in this pos. If whatever voxel we're passing in here is outside of the world, we're just going to return 0. There's no point in messing around. We don't need to know anything about anything about voxel that is outside of the world, because we're never going to generate it. So the way we get our proper value is we return world.blocktypes, and then the ID that we want is the ID from our voxel that we're passing in. However, the information here, this pos value, is local only, so it's only going from 0 to, I think we're set at 15 at the minute, but whatever your chunk width is set at, this position value is only working within that frame of reference, and the get voxel is worldwide. So we need to take that into account, and we do that by adding our position value. And if you remember, if we didn't have our position this here, then we would have had to have typed that out anytime we wanted to reference the position. And then is solid. So we're looking into the block types class. We're getting our ID from the get voxel thing using this position to figure out what the voxel is, and then we're doing checking the is solid function of that block type. Only doing this if it is outside of the chunk. If it's inside the chunk, we just get this information straight from the voxel map, because we wouldn't be able to get this far if we hadn't populated the voxel map, so we know that we have information there. Okay, so I had to run off and answer the door, and when I came back I had a bit of a brain fart in trying to remember exactly where I was, and while I was figuring it out, I did notice that there were a few mistakes that we just need to quickly fix. So the first thing is, obviously, we need to add our position data into here, because this is calling the get voxel function, as I think I mentioned before, which is a global value, so it needs to know where in the world it is. It can't just rely on this local data. So we need to add our position there. And the other thing is this here. This returns true if it is in the if the voxel that we're checking is in the world, and obviously we're only returning not if it's out of the world. So that wants to be if it's not in the world. And the final mistake is down here. This isn't working with an array, so this does not want to be -1, like I was saying. I apologize for this. Because that's just telling us whether it's in or out of the world. It's not pulling from the actual array, and for the same reason this needs to be if it's greater than or equal to 0. And then with all that being done, I think if we press play now, once it catches up, we should have our chunks and they should be drawn properly. Yep. So now we're only drawing the edges of the chunks when they are at the edge of the world, which we can turn on or off if we wanted to. I'm going to leave them on just because it gives us something to look at, and just to show that everything's working fine, we'll change the the world size, I don't know, 8, just a different value just to show you that it's doing what it's supposed to do. And there we have it. So that's fine for a static world that you're only going to generate once, but these worlds are a lot bigger than 5 or 8 or 10 or even 50 chunks, so we need to manage this a little bit better. So the first thing we're going to do is we're going to create ourselves a view distance. So what this will be, as it sounds, is just going to be the amount of chunks with which the player can see. So if a chunk is beyond that distance from the player, it won't bother being shown on screen, or it won't generate it if it's creating the chunks in the world generation function. It will only show them if they're within this distance of chunks from the player. So we'll just call it, I want it to be static. Static, read only int. And just in case you're wondering, these values can be rearranged later so that you can have them as options. This is just for the sake of this tutorial. We're having them in this single static read-only class, but you would have your like your chunk width and your chunk height would be a fixed thing. You don't really want people changing that, but the world size, for example, and the view distance, that's the sort of thing that the player should be able to change. But for now, we're just going to keep things nice and simple like this. So we're going to call this view distance in chunks. We're not going to have a view distance in voxels, but it's just nice to keep everything very clearly marked. So what we're going to do is we're going to change the world size in chunks to a very large number. We'll call it 100. And then we will have our view distance be 5. So then we need to go into our world class and we need to change our, well, the first thing we need to do is we need to have a transform reference for a player. We'll make this one public actually. And for now, our player is just going to be the camera. And then we also are going to have a, we'll make this public as well. A spawn position. Now our spawn position is quite easy to work out. For what we're going to do is so you may have the way this is working is we have this potentially giant array, which is storing all the chunks and potential and keeping space open for potential chunks. Because we're having this fixed sized array, and there are other ways of doing it that are more dynamic that only have arrays the size of the amount of chunks you have and all that, I'm choosing to do it this way because it's a lot simpler to follow along, and I think it feels more efficient than using, for example, a list. I'm not saying it's the most efficient way to do it, but I do think it's the most simplest way to illustrate how I'm doing it. And like I say, this is by no means meant to be a tutorial for people who know what they're doing. This is meant to be very beginners. If you think this seems basic, then you're probably already beyond where I am. So feel free to go find a much better tutorial that goes more in depth than I am. So because we're saving all this, basically our world starts at 0, 0 in the bottom left hand corner. Spawn is not 0, 0. So right now our world is going to be 100 by 100 chunks. So to set spawn, we're just going to say spawn location equals, and then it's new voxel data dot world size in chunks divided by 2. Because our chunks are completely solid all the way from top to bottom right now, we can just pass in the chunk height for this one. Obviously, when we have more nuanced terrain, when we have actual terrain, hills and stuff, we will need to find out the height of the position that we're going to put the player on. But for now, we know the height because all the chunks are full. And then the Z is the exact same as the X. So that puts us smack bang in the middle of the world. But of course, it helps if you name it correctly. So that puts us smack bang in the middle of the world, and then we're going to use that to place the player. So when we generate world, we'll generate the world first, and then we will place the player dot position equals spawn location. Keep doing that. Maybe I should just rename it to spawn location, spawn position. So right now we still have this function that's generating the world is doing the full world size in chunks, which we don't want it to do. Now that we've changed the world size, it's quite large now. We only want to do the view distance. So our view distance is, what did we set it at? 5. Our view distance is 5. So that means that there should never be a square of more than 10 chunks, 5 in any direction away from the player. So we will start, first off we need to get our center point, which we know is voxel data dot world size in chunks divided by 2. So that gets us the middle of the world in sorry, can't put a float there. The middle, that gets us to the middle of the world in chunks. And then we need to, from that, we need to minus voxel data dot view distance in chunks. So that gets us, that should get us, let's say the center is 50, and then obviously the view distance is 5, so that should get us to 45. So we start in x equals 45 with the current values that we have. And then we can just copy this for the value that we're foring to, and we just change this to plus. So now we go in from the center plus the view distance, and then we can copy all of this for here because again it is exactly the same. And I've just realized this is actually, I'm sorry about this, I keep making mistakes. This needs to be times by the chunk width. Otherwise it's going to be a drastically wrong value. Just copy that whole cell. Now if we try that, we should have... oh, no, the camera is still drastically wrong. Oh, yeah, sorry. It would help if you set the spawn value before using the spawn value. So, yeah, we're going to have to raise the height of the camera because right now it's appearing pretty much on exact level with the ground, so you can't see anything. But as you can see, the camera has been moved to the dead center of where the chunks are spawning. Now the world extends out another 40 blocks in either direction. Sorry, another 20 blocks in either direction. We can't see that now because it's only drawing the view distance. But let's just quickly change let's give this a little bit more height. So at least now we should be able to see it. Yeah, there we go. Right, so what we need to do now, this is the slightly tricky bit, is we need to update that during game time, because there's no point having a view distance if it only works, you know, when you're generating the world. View distance is for runtime. So let us create another function, and we're going to call this one check view distance. And it will take in, what do we want to take in? I don't think, no, we don't take anything on this one. So we need to get the player's position as a chunk. So whichever, like as in wherever the player is in the world, we need to figure out what chunk that position puts the player in. And to do that, we're going to create another little function just to make that easier, because we're going to use this again in other places. So we're just going to call this get chunk code, sorry, from vector3, and it will take in a vector3, funnily enough. Nice and simple function. All it's going to do is create an x and a z value. Math f.floor to int. We're passing in the pos x and dividing it by chunk width. And then we want to do exactly the same for z. And then we will return a new chunk card using those values. Now we can use that to create a new chunk card. We'll just call it card like we usually do. And it will equal get chunk card from vector3, and we're going to pass in the player.position value. I've already got a card in this. No, you just don't put a new there. Right, so we then loop through int x equals card.x minus voxel data dot view distance in chunks. And then x wants to be less than card.x plus voxel data dot view distance in chunks x plus plus. And then we shall just copy and paste this for our z value. And what this is doing is basically doing the exact same loop that our generate world thing is doing, only instead of working from the dead center of the world or the spawn position, it is working from wherever the player is currently standing. So within this loop, first thing we want to do is check that this chunk is in the world. Card, yeah, sorry, just passing in card. If chunk is in world, then we do the stuff that we're about to do. So the first thing we want to do is if chunks card.x card.z is equal to null, then we want to create this chunk. Because it means that it's within the world, it's not outside the boundaries of the world, so we do want there to be a chunk there. If we got to this point in the code, then it's within view distance of the player, and if this equals null, that means it's not been made before. The actual thing, the chunk has not been generated before, so we want to generate it. Else, oh yeah, nope, sorry, that's all we need for now. So if we run no, sorry, if we run that, it will make absolutely no difference because we haven't got an update. Check view distance. Sorry, these should actually be the for loop values. It was probably obvious to you as you were watching it, but as I've said, I'm not 100% lucid right now. So if we try that now, we should have a rudimentary view distance system. Okay. As you can see, it generates them as you move around, and theoretically, if I run right to the edge of where the world ends, oh, we get an out of range exception. Oh yeah, the sorry about this. The error is because we are not using the x and z values here. Again, can only apologize. So now we are generating chunks the world over, and it will stop when we get to, oh sorry, I'll just take that angle off the camera, and it will stop when we reach the edge of the world. Now you may notice the problem right now is that the view distance isn't much use to us when it is leaving behind all the chunks that we generate. We don't want it to leave them behind once they've been generated. So we need a way of knowing which chunks are active, and deactivating those chunks once they are out of view distance. So the way we're going to do that is we need a list. And I said we weren't going to use lists for storing everything because it's not very efficient, but this will be a relatively small list. And we're going to call this, we're going to use chunk chords, because we literally the only information we need is the x and z value. Everything else we can work out from that. In the same way that we look up our block type from the byte number, we can look up the chunk from the x and z value. And we'll just call it, nice and simple, active chunks equals new list and then what we're going to do is every time we create a new chunk, because we're not going to create any chunks that aren't active, we don't create chunks off in the distance that aren't being seen, we only create a chunk when it is going to be on screen. So anytime we create a chunk, we will add it to the active chunks list. Chunks xz, new chunk chord xz. So now that list will keep all the active chunks. Obviously we now need a way of removing chunks from that. So if we go back to our check view distance script, we're going to go straight to our if statement where we check if the chunk exists in our chunk map already, and we're going to have an else on there, and that else will be to check if our chunk is active. So this is if the chunk exists, we need to check if it's active. So chunks xz dot is active, and if you remember, this is pulling from our little function we made just to make life easier on ourselves that I have lost. There it is. That's pulling from this. All it's doing is checking the game object itself. So if it is active, if it's not active, then we want to make it active. We also want to spell else with an L and not a K. So chunk, if it's not active, make it active. Equals true, and then we want to add it to the active chunks. Right, but we now need to be able to disable the ones that are out, and we're just going to do that by setting them to inactive, but we need to know which ones are inactive or need to be made inactive. So what we're going to do, the way we're going to do this is we're going to create a temporary list here, and we'll call this list previously active chunks. So chunk chord previously active chunks equals new list, and we're going to copy in the active chunks list. So whatever chunks are active at the time we run this script here, sorry, that's incorrect syntax. Chunk chord active chunks. So whatever chunks are active at the time we run this function will be added into this list. Within this if statement here, where we're checking if the chunk is in the world, so whatever is happening here is with a chunk that is a valid one that we can work on within the actual world itself. We're going to do a quick loop through our previously active chunks. I equals not, I is less than previously active chunks dot count I plus plus. And we're going to need to do a little, right, so what we want to do here is for each item in this list, we want to compare it to the current chunk. So if the one of the items in the previously active chunks is this chunk, the one that we're currently looking at, which we know is within the view distance, otherwise we wouldn't be looking at it, and we know it's within the world, otherwise again we wouldn't be looking at it. So we know it is a chunk that we want to be active and on screen. So we need to compare it against the previously active chunks. And to do that, we're going to create a little function inside here to just compare this chunk code against another chunk code that we pass to. And we'll do that with a public bool, and we'll just call it equals. It will take in one chunk code, which is the other chunk code, the one that it's being compared to. If other for some reason equals null, we're just going to return false. Else if other.x is equal to x and other.z is equal to z, return true. Else return false. So all this does is we can pass a chunk code into here, and if x and z are the same, it will return true. It's just a simple this chunk code is the same as this chunk code function. So inside our for statement here, we can now do a bit of a check. What we want to do is if previously active chunks I dot equals the one we're working on, which is new chunk code xz, then we want to remove it, and this is why we used a proper for loop instead of a for each loop, because we needed to be able to access the index that we're currently working on. Remove at I. So what that's going to do is we start this function with a list that contains all the chunks that are currently active on screen. We then do a check to see which chunks are currently within the view distance. Any chunks that are within the view distance will then be removed from that list. So once we have finished, we know that any chunks left in that view within this list here are ones that were previously in the view distance but are no longer in the view distance. So then at the end of the function, I've got the right curly bracket here. So then at the end of the function, we just do a quick, and now we can use a for each, we just do a quick loop through chunk code, we'll just call it C, it really doesn't matter, in previously active chunks. We use that c.x, c.z is, dot is active equals false, and we just make it inactive because we don't want to remove the chunk completely, because then if we ever wander back into that area, we're going to have to generate it all over again, and that's very inefficient. When you get to a certain size, you will have to worry about storing too much stuff in the memory, but for now that's not a problem for us. So now if we run it, we should only see chunks within the view distance. Yep, so if you notice, it is following us, essentially. Now, you can't really tell. I can barely tell looking at it on my screen, and I imagine once it's any frames lost through the screen capture and being uploaded to YouTube, it might be even more difficult to tell. But there was a bit of a hit on the frame rate, and that is because it is doing this every frame, regardless of whether it needs to, and it won't always need to. We only need to do that if the player has moved from the chunk that they moved from one chunk to another. So we need to keep track of that. And the nice and simple way of doing that is we just have ourselves a chunk card value that we will call player last chunk card, and all that means is it was the last chunk that the player was known to be on. And so we will put when we start, we want to generate it from the beginning, so we will put player last chunk card, which is also the first chunk card, but obviously after we've generated the spawn position, we will use our get chunk card from vector3 function, pass in our player dot position. So now our player last chunk card is set to start with, which will be on current values that we have entered will be 50, B50 or whatever it is. And then in here, we're going to do a quick check, and it's if get chunk card from vector3 player dot player dot position dot equals player last chunk card, then we want to check the view distance. So we're only checking the view distance now if the player has changed, and then obviously we need to make sure we update that player last known. In fact, you know what, we will store a value for it. So we'll just do this in the update loop. So we've got a player last chunk card. We'll just have chunk card, player chunk card, and then we'll set that in our update loop. Equals get chunk card from vector3 player dot position, and then we don't need this anymore. We can just use our player chunk card. If player chunk card equals player last chunk, if player chunk card does not equal the player last chunk card, then do the view distance check. If it does equal it, it means the player is in the same chunk, and we don't need to check the view distance again because we know the player hasn't moved or hasn't moved far enough. Obviously, the chunk is however many blocks wide, 15 or 16. So it means that in this case, the player will move 15, 16 blocks without the view distance updating. But that's a judgment call. Maybe you want it to update every single block. Personally, I feel that's way overkill, but that's entirely up to you. So it won't look a right lot different to the last time, but as you can see, everything's still working the same. It's just running a tad more smoothly now because it's not updating every frame. It's only updating when it actually needs to. And if you disappear off the edge of the world, it disappears with you. And that is the end of this tutorial. I'm sorry it was a bit of a slog, and there was an interruption in the middle. Hopefully everything's clear. If not, the code will be available as always. You can look through it yourself. I've tried to keep things as simple as possible. I might go through and add a few annotations in the code before I upload it, so that makes things a bit easier for you. But in the next tutorial, we're going to get to actually making this look like actual terrain as opposed to just a flat grass plain. So hopefully that's one for you to look forward to, and I will see you next time.